Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on period properties within a group. In our last lesson, we learned about nuclear charge and atomic radius as general trends across a period of the periodic table. We learned that as we move across a period from left to right, the number of valence electrons each element has increases. We learned that in any given period, the number of energy levels, or main shells, remains the same. Electrons fill the same energy level until they reach stability. We also learned that the atomic number increases as we move from left to right across a period. There is an increased number of valence electrons being added to each shell. Therefore, there is an increase in the effective nuclear charge. In today's lesson, we will learn about more general trends across a period, including ionization energy and electron affinity. We will begin by discussing ionization energy. Students, I am sure that you remember learning about factors that can affect ionization energy. Several lessons back, we spoke about 5 factors specifically. Can you remember what they were? Please list those factors now.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, everyone. I trust that you did not find this activity too difficult. Several lessons back, we spoke about 5 factors that can affect ionization energy. These factors include atomic size, effective nuclear charge, the types of electrons, the screening effect by inner electrons, and electron configuration. If you were able to remember all 5 of those factors, then you have great memorization skills. Let us move on. When we are discussing general trends across a given period in the periodic table, there are 2 factors specifically that have an effect: the atomic size and the nuclear charge. As atomic size increases, less energy is needed to remove electrons. Also, the smaller the effective nuclear charge an atom has, the less energy is needed to remove electrons from it. These 2 factors cause the ionization energy to increase across a period. Students, this table shows the ionization energy values of period 3 elements. Please copy this table onto a piece of paper. As you can see, there is a general increase in the first ionization energy across the period, from sodium to argon. Students, why do you think that is?
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, everyone. Let us discuss the answer. The nuclear charge increases steadily across a given period from left to right. In addition to this, the nucleus increasingly attracts each extra valence electron. This raises the effective nuclear charge and decreases the atomic size. This causes an increase in ionization energy across the period 3 elements. You might be wondering why the first ionization energy of aluminium is lower than that of magnesium, and also why the first ionization energy of sulfur is lower than that of phosphorus. For several reasons, there are a number of irregularities that can be seen across a period. The first ionization energy of magnesium is larger than that of aluminium because of completely filled sublevel stability. The first ionization energy of sulfur is lower than that of phosphorus because of half-filled sublevel stability. It is difficult to remove an electron from an atom that has a half or completely filled outer sublevel. This explains these atoms' ionization energy. Let us move on with our lesson and discuss the general trends of electron affinity in regards to periods. There is a variation in electron affinity of elements in the same period. This is due to the changes in nuclear charge and the atomic size of the elements. Looking across the periods from left to right, there is an increase in electron affinity because of the increase in effective nuclear charge. This means that the elements display a stronger attraction for the addition of an extra electron. Students, let us do one more activity so you can start using the general trends we are learning to identify specific elements on the periodic table. In a moment, you will see a periodic table and a list of descriptions. Please state which element is being described by each. You may begin now.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. How did you do on that activity? Let us go through the answers together now so that you can make sure your answers are correct. The element that has the smallest atomic radius in group 6A is oxygen. The element that has the largest atomic radius in period 5 is rubidium. The element that has the highest first ionization energy in group 1A is lithium. The element that is the most metallic in group 3A is thallium. Finally, the element that has an extremely low electron affinity in period 3 is argon. In today's lesson, we learned about trends in the properties of elements across a period of the periodic table, including ionization energy and electron affinity. We learned that nuclear charge and atomic size account for the general trend in ionization energy across a given period. We also learned that across a period from left to right, electron affinity increases because of an increase in effective nuclear charge. This brings us to the end of our lesson for today. Until next time, thank you, teacher. Thank you, students.